Okay, frames of reference or reference frames. Any measurement of position, distance, or speed must be made with respect to a reference frame or frame of reference. For example, let's say we have Superman flying along at a speed of 25.0 meters per second relative to the ground. We also have a train speed of the train traveling at 13.9 meters per second relative to the ground. My question to you is this: what is the speed of Superman relative to the speed of the train? Well, Superman's speed relative to the train is just the difference between these two values, which ends up being 11.1 meters per second. So Superman is traveling at a speed of 11.1 meters per second relative to the train. So Superman's initial speed relative to the train is 11.1 meters per second. Let's say that once Superman reaches the train, he starts to accelerate at 2.0 meters per second squared. Let's say that Superman is going to overtake the train or travel a displacement of 400 meters because the train is 400 meters long. And the question is, this is how far Superman's going to travel. How far does the train travel? And the amount of time it takes Superman to overcome the length of the train. So another thing we need is the time here, because the time it takes Superman to overcome the train is the same time for the train itself while it's traveling. So we're going to look at our kinematics equations. So to review our equations, we have three of them. One is v squared is equal to v sub naught squared plus 2a delta x. Another one is x is equal to x sub naught plus v sub naught t plus 1/2 a t squared. And lastly, v is equal to v sub naught plus a t. In this case, we don't have the time, so we're not going to use the first two equations right away. What I would like to do is use this top equation, because I have the initial speed of Superman, 11.1. The acceleration is given, and the length of the train, or how much Superman's going to travel, 400 meters. By using this top formula, I can find v, and so I would like to do that. So I'm going to use the top formula, and I'm going to solve for Superman's final speed after he overcomes the train. So to do that, I need to take the square root of both sides. And so the speed of Superman after he overcomes the train is going to be the initial speed of Superman squared. The acceleration was 2, and that's 400. So that final speed of Superman when he overcomes the train, let's see if I have that here. Well, I don't have that value right now, but with the magic of calculators, let's get that. I have 41.5 meters per second. Okay, now we're going to use that value in another equation. And the equation that I would like to use will be v is equal to v sub naught plus at. Now, I can find the time here by just doing a little bit of algebra. So v minus v sub naught divided by a is going to give me the t. And this is all for Superman. So the final speed of Superman, we said, is 41.5. This is all relative to the train, of course. The initial speed of Superman relative to the train was 11.1. And the acceleration of Superman was 2 meters per second squared. And solving for that time, I should get 15.2 seconds. I'm going to double check that right now. Yes, 15.2 seconds. Now that's also the time for the train. So now let's go to the train. We also know there is a speed of the train, or velocity of the train, that's equal to the displacement of the train during all this time divided by the time that we just solved for. And we ultimately want to find what is that displacement of the train. So we're going to solve for the displacement of the train by multiplying time on both sides. And I get the time multiplied by the velocity of the train is equal to the displacement of the train. So the displacement of the train is going to be the velocity of the train. Now this is relative to the ground multiplied by the time we just solved for. The velocity of the train relative to the ground is 13.9 meters per second. And the time is 15.2 seconds, which we just solved, because the time for Superman is the same time as the train. And I end up getting 211.28 meters, because the seconds do cancel here. And you notice that in my multiplication problem here, my first number in the calculation has 3 sig figs. My second number here has 3 sig figs. So my answer should be rounded to whichever number in my calculation has the lowest number of sig figs. In this case, they're both 3, so my answer will be rounded to 3 sig figs. So my answer is 211 meters is the distance the train travels. Now just in review here, when we looked at Superman, we looked at Superman's speed relative to the train. And at the end of this problem, when we used the velocity of the train, we looked at the velocity of the train relative to the ground. It's really important to know your frames of reference.